Hello, good morning, good afternoon. Welcome from wherever in the world you're joining us today. We are excited to present a webinar to you today in regards to the high temperature bearing test rig consortium and accompanying test method. We have had a small task force working over the past several months to build together a model for the consortium and are excited to share that with you all today. Please note that today's webinar will be a repeat presentation of last week's webinar. However, the live Q&A portion could be a little bit different today. Today's presentation will last about 25 minutes and will be led by Andy Wainick. And then we will have live Q&A facilitated by Gary Dudley of GKD Consulting and David Turner of Citgo. We encourage you to post your questions throughout the presentation, and you can do that one of two ways. The first way is through the Q&A bubble at the top of your screen. If you do not see the Q&A bubble at the top of your screen, that's no problem at all. That might mean that you have an older version of Teams, and you are still able to submit questions via the chat feature. Please note that all questions posted will be seen by all attendees. Please also note that today's webinar will be recorded and be made available to you following today's webinar, along with a copy of the slides and copy of the Q&A that came through. Additionally, I'd like to draw your attention to a link that is available in the chat. That is a link to our survey, and we encourage all of you to post your thoughts from the survey. Please let us know if you're interested in participating in the consortium or have additional questions following this webinar, and one of the gentlemen will follow up with you. So without further ado, I'd like to turn it over to Andy Wainick to get us started.
Thanks, Crystal. And again, I add my thanks to everyone who is attending. And yes, this presentation has to do with the NLGI project for the development of a new high temperature bearing test rig and associated new ASTM test method. A little more than a year ago, at the 2024 annual meeting of the NLGI in San Antonio, Joe Kaparick gave a presentation in which he summarized work that had been done thus far at that point towards the development of this new test rig and test method. A little more than a month ago, at the NLGI annual meeting that was held in Fort Lauderdale, Florida, I presented a brief update of that same information. The presentation you're going to see today is for the most part not going to contain any of that information. Instead, I want to talk about additional details of this project as we begin the efforts to actually move this project forward. Towards that end, as Crystal mentioned, a task force has been set up. The members of that task force are David Turner, Gary Dudley, and myself. This is the outline of the presentation that I'm going to give today. First, we're going to talk a little bit about why this project is needed now. From there, we'll move to the benefits of being a member of this consortium project. Next, we are going to move to the subject of how this project will be structured and administered. Then, a topic that I'm sure everyone is interested in, what will be the cost of being a member of this project? And then finally, we're going to talk about some details of what the new test rig will be able to do. Or another way to put it is, what will be the functional requirements of the new test rig? I'm going to be using that term functional requirements multiple times in this presentation. And that is simply, what are the specifications of performance for the test rig? What will this test rig be able to do? What are its limitations? And so forth. So with that, let's move to the first topic and discuss why this project is needed now. And to do that, we need to answer first this question. Why do we need a new high temperature bearing test anyway? Why won't ASTM D3527 suffice? Well, if you know anything at all about the development of lubricating grease bearing test methods, you already know the answer to that question. The current method, D3527, has extremely poor repeatability and reproducibility. Multiple attempts over decades to improve D3527's statistical integrity has failed. The need to develop a new test method for high temperature bearing performance of lubricating greases has in fact been recognized for not only many years, it's actually been recognized for decades. Towards that end, an ASTM task force was established in December 2019 to address that issue. That task force had multiple meetings and discussions occurring from October 2020 through July of 2023. Early on in those meetings, it was recognized that simply modifying D3527 and the D3527 test equipment was not feasible. The test equipment for D3527 uses old, outdated componentry. As I mentioned, previous attempts to fix this had failed. And the bottom line is, if you were to use all of the modern technology, componentry, electronics, and so forth needed to update the D3527 test equipment to make it work as it needs to, you'd end up with a brand new test machine anyway. So that brings us to this question. Why do this now? I mentioned the need for a new piece of test equipment and a new test method has been recognized for decades. So why now? What's different now? Well, what's different is the NLGI high performance multi-use HPM specification and the 4 additional performance specification tags. Those specifications had been already established by the time the functional requirements for a new test rig had been established. And as I indicated, we'll talk about those functional requirements for the new test rig at the end of this presentation. When the HPM specification was being developed, there was a recognized need for an additional tag or tags for high temperature performance and or long life performance. They were desired, but those tags simply were not feasible because there wasn't an acceptable bearing test that needed to be the centerpiece for any such additional tags. Now I need to point out the high temperature tag and the long life tag are a combination of the two. A new bearing test method will not be the only thing in that tag. There are other obvious tests that will need to be incorporated for any of those new tags or tag. However, they are not sufficient. We need a new high temperature bearing test and test equipment to be the centerpiece of that new tag or 2 tags, depending on how it turns out to be. There were multiple discussions that occurred with the members of the ASTM task force that I previously mentioned and with the NLGI. As a result of those discussions, the decision was made to form an intercompany consortium to develop a new high temperature bearing test rig and associated test method. That consortium is to be managed by Southwest Research Institute. With that, let's talk a little bit about the benefits of being a member of this intercompany consortium project. All members who remain in the project for all 3 of the anticipated project years will retain their test rig at the conclusion of the project. Furthermore, members will obtain their test rig at today's manufacturer's cost, which amounts to $60,000 spread evenly over the 3 anticipated years of the project. Members will have access to all round-robin test data that is generated during the project. And the 4th bullet is, frankly, for me, one of the most important. They will gain insight into how the new test rig behaves with different grease chemistries. People who are well experienced in lubricating grease science and the testing of lubricating greases know that every piece of lubricating grease test equipment has built into it, not intentionally, but nonetheless built into it, certain biases with regard to certain chemistries. The Temp test likes active sulfur chemistry. The Phalanx Pen and V-block test loves phosphorus chemistry. We all know this. The test equipment's not designed intentionally that way, but that's just the way the universe works. And if you're a member of this project, you get your piece of test equipment, you will be able to use it to gain early insight into what is going to work well with that piece of test equipment. Members will also have hands-on training and experience in using the new test rig and running the new ASTM test method. And they will have the immediate ability to do the required in-house grease test development work to meet whatever new HPM high temperature / long life tag or tags are developed once they are developed. So let's move to discussing how this intercompany consortium project will be structured and administered. That brings us to an obvious question. Why a consortium? Well, developing a new grease test method and test equipment and getting it ASTM approved can take not only years, but decades. A consortium properly managed can reduce that timeline and increase the likelihood of success. Southwest Research has vast knowledge and experience managing such consortiums and keeping them on schedule. SWRI also understands the required legal issues involved in intercompany consortiums. SWRI policy also ensures that all intellectual property remains with the clients. All equipment design IP will remain with the respective equipment manufacturers. All test data IP generated during the project will remain solely with all consortium members. And finally, Southwest Research will prepare and have contracts signed by all consortium members, and part of those contracts will legally ensure all the IP protection that I just mentioned. So how will this consortium be set up? Phalanx and Kohler would be members of this intercompany consortium and would provide the new test rigs to consortium members. Kohler and Phalanx have expressed a desire to be part of this project. All other consortium members would be potential users, and by that I am referring to specifically grease manufacturer marketers, additive suppliers, bearing manufacturers, independent testing laboratories, major end users, and the NLGI itself. All members, as I've already pointed out, who remain for the entire project will walk away with a test rig as part of their consortium membership. So let's talk a little bit more about how this project will be implemented. As I've already pointed out, we anticipate a 3-year project. The equipment manufacturers will begin their test rig development once consortium members join to fund the project work. Actually, that's not entirely true. Both equipment manufacturers, Kohler and Phalanx, are already well underway in developing the new test equipment. They are not starting from square one. They've already made very significant strides in the design and the development process. So that part has actually begun. As I alluded to, funding for this project will come from consortium member buy-in. The funding will pay for all equipment manufacturer development costs, except for the one test rig that each equipment manufacturer develops and keeps for themselves. Funding will pay for all Southwest Research administrative costs. Test equipment manufacturers would develop equivalent test rigs that they will verify meet all the functional requirements. And as I pointed out, each equipment manufacturer will keep the very first rig that they develop and build. And the reason for that is that each equipment manufacturer will be part of the project and will be part of the round robin testing. And that first rig that they develop, validate, and verify as meeting all of the functional requirements, that will be their rig that they will build at their cost and will use for their participation in the round robin testing. All other consortium members will receive their test rig from the equipment manufacturers, and they will use those test rigs for the round robin testing program. And as I pointed out, once the project is done, they keep their test rig. Consortium members would join in year one. All the test rigs would be built and performance verified by the individual equipment manufacturers in project year one and as necessary in project year two. The test greases that would be used in this project would be manufactured and distributed to all consortium members in project year two. The test procedure that would be used will be determined also in project year two. Round robin testing will be done in year three, and if the previous bullets are done in a timely fashion, the round robin testing can actually begin part of the way through year two, but it would be concluded in year three. All consortium members will participate in all round robin testing. The test procedure development and round robin will be coordinated with the appropriate ASTM subcommittee. The final test procedure and all round robin test results would be submitted to the ASTM for approval. And as I pointed out several times before, once the project is completed, the consortium members will retain their test rigs. It is anticipated that there will be one in-person consortium meeting each of the 3 anticipated project years, and those meetings would be managed by Southwest Research Institute and tentatively would take place at Southwest Research's main campus in San Antonio, Texas. So I've mentioned multiple times that Southwest Research would be managing the consortium project. So what will their administrative tasks be? Well, they will administer the project startup. They will administer, as I previously pointed out, getting the contracts developed and signed and agreed to. They will organize all in-person meetings, at least once a year, as I pointed out, and they will cover their own costs for catering and for meeting rooms. And if it's determined that the in-person meetings would take place someplace else, then Southwest Research obviously would cover their own travel costs to get to wherever that venue is. They would be responsible for the general management of the consortium through the entire run of the project. They would organize, run, and take minutes for the online meetings, which we anticipate to be 6 per year or as needed. They will respond to consortium member questions during the meetings. They will also provide an institute-level tribologist during all meetings and to answer any technical questions for which such an expertise would be necessary. That tribologist, as I understand it, will be Dr. Peter Lee, and I know some of you in attendance to this webinar today know Peter. Southwest Research staff will travel as needed to check on rig builds and manufacturing processes to keep everyone on track. Just having emails saying that people are on track often does not result in a final on-time delivery. So the Southwest Research would manage the gathering of all the round-robin data and verification process, and as necessary, they will travel to the round-robin labs to answer technical questions and provide in-person training on how to operate the test rig. And they would also, as needed, perform QC checks on the test rig. So now, cost of membership. This bar chart provides the calculated membership costs for each of the 3 anticipated project years. The blue bar is for year 1, the red bar is year 2, the green bar is year 3. Now I want to point out 2 things about this bar chart. The first thing is you will notice that the year 1 costs are always higher than year 2 and year 3. And there is a reason for that. The reason is simply this. In year 1, the 2 equipment manufacturers that we thus far have, Kohler and Phalanx, will be doing an additional amount of test work needed to verify and validate that first piece of test equipment that they build and will ultimately keep for round-robin testing. That initial amount of testing needs to be more complete and more rigorous and more all-encompassing than the tests that will be done for subsequent test rigs, for obvious reasons. That additional cost of testing will be paid for by the consortium members, and it will be split up evenly. That additional test costs for validating the test equipment won't be necessary for the additional test rigs if the first test rig is done tested and evaluated correctly, which is why the costs for year 1 is always greater than the costs for years 2 and 3. The second thing I want to point out about this chart is you will notice that the costs are slowly receding. Actually, they're asymptotically approaching a value if you would take this out to an infinite number of consortium members. The x-axis on this plot goes from 15 total members to 25 total members. You will remember that the NLGI and the 2 test equipment manufacturers, Kohler and Phalanx, are members. So if you have 15 total members, that means you have 12 additional members besides the equipment manufacturers and the NLGI. Likewise, if you have 25 total members, that means you have 22 additional members other than the NLGI and the 2 equipment manufacturers. And as you increase the total number of consortium members, or stakeholders as they're referred to in this bar chart, the fixed costs, such as the Southwest Research administrative costs and the costs to pay for the validation and testing of the test rigs, and the cost for their own test rigs, which amounts to $20,000 each year, the sum total of that will gradually decrease. And that's why you're going to approach something a bit more than $20,000. The $20,000 is the cost per year for the test rig that each member receives and keeps. The additional costs beyond that are those other costs that, when spread out, decrease depending on how many members are in the project. And that explains why the bars are gradually decreasing as you increase the number of members. Now, this table captures some of the numerical values from that previous bar chart, specifically for 15 total members, 20 total members, and 25 total members. But it also includes new information that the previous bar chart did not contain. That new information is what you see in red. As I mentioned previously, the NLGI itself will be a member of this consortium. And the NLGI Board of Directors has approved the NLGI to contribute $100,000 towards the Southwest Research administrative costs for this project. In addition, NLGI will be paying their $60,000 for their test rig, which will be sent to Southwest Research Institute, and then people at Southwest Research Institute will use that NLGI piece of equipment for the round-robin testing. And then also the additional testing that's done for that first test rig in year 1. That is why you see the numbers for Southwest Research being what they are, depending on the total number of members. So let's move to the final section. Let's give you some details of what the new test rig will be able to do. In other words, what are the functional requirements of this new test rig? Well, the ASTM task force that began meeting in 2019 and concluded in 2023 agreed that any new high temperature bearing test rig should have the following features. It needs to use different bearings more representative from today's applications. D3527 uses bearings from a 1960s automobile. It needs to have the ability to use different bearings instead of just one. It should utilize the improved technology that we have today to control and measure all the variables, the parameters of this piece of equipment. It should utilize improved technology to determine the failure event. And if you do those bullets correctly that I've just mentioned, you are supposed to, or you should result in improved repeatability and reproducibility compared to D3527. You should preferentially have the flexibility to use this new piece of equipment not only in a new standard procedure, but also to be able to have it run at varying conditions as a research tool. I need to point out that neither D3527 nor any other established bearing test procedures such as D3336, FE9, so forth, has all of the above 6 features and at the costs that I've previously described in the previous slides. As a result of these considerations, important parameters for the new test rig were identified by the ASTM task force. Those parameters were the bearings that would be used, the kind of motor drive unit, the load that would be used, the speed, the temperature, the torque that's applied, and the duration of the test and how you would determine failure. Using these identified parameters, the functional requirements for the new high temperature bearing test rig were established by the ASTM task force. And here they are. First, the new test rig will have to have the capacity to use at least the 5 different bearings that you see enumerated here from 1A through 1E. There will be 2 bearings per shaft. The motor can be either a DC or servo at the discretion of the equipment manufacturer. However, whichever is chosen, the piece of equipment that results must meet all of the other functional requirements. And likewise, the equipment manufacturers, they can use either a direct drive or a belt drive. However, all of the other functional requirements must be met. The speed needs to be variable up to 3,600 RPM with precision of plus or minus 2%. Load requirements are 0.5 to 1.5 kilonewtons dynamic axial loading with precision of plus or minus 2%. Radial loading is optional at the discretion of the test equipment manufacturer. Temperature should be adjustable to 200 degrees Celsius with a tolerance of plus or minus 2% and a precision of plus or minus 1% for temperatures of 200 degrees Celsius to the top temperature limit. And it should have the capacity, the capability to control cool down time temperature as per whatever future test method requirements are developed. The torque measurement sensitivity should be plus or minus 0.2 Newton meters. And the failure determination mode, you should have the capacity to detect failure torque increase from steady state and set shutoff signaling failure by an adjustable amount as per the future test method. Likewise, you should have the capacity to measure startup time and set shutoff signaling failure, again, by an adjustable amount as per the future test method. It should have the capability to measure the bearing wall temperature and to set shutoff signaling failure by an adjustable amount as per the test method. And it should also have as an optional feature being able to detect vibration. And with that, I'm going to turn the reins of this webinar over to David and Gary for questions.
Hello, everyone. We have our first question in the Q&A. So I encourage everyone, if you have any questions, submit via the Q&A button at the top, or if you want, you can drop it in the chat. So first question we have in is, are you going to allow members outside of the US to participate in this consortium? And the answer is yes. It's open to all companies and all countries. So feel free to express your interest and we'll get back to you.
Yeah, I don't think we're going to allow anybody from North Korea to join, but other than that, anybody who wants to join in is welcome. And just note that the survey that was mentioned is in the chat as a link. You can click on that. And here's a question from the chat. Will everyone part of the consortium get a Phalanx and Kohler test rig, or will they get one or the other? Yes, you'll get one rig. It will be either the Phalanx version or the Kohler version, and it'll be pretty much random as to which one you get unless there's a driving reason for you to get one or the other, like you have some particular relationship with one company or the other. Perhaps you can make a request for that company's rig, but otherwise it'll be just a random distribution of rigs to the participants.
Another question we had is, how do we define year one? Year one will be basically the day it will start, the day it kicks off. So year one, theoretically could start February 1st, that type of thing. So that's how we're looking at a year.
Another question is, how do you have standard test bearings? Do you have a possibility to add parallel test units to be able to generate statistically significant results? Yes. As part of the initial round robin testing program, everyone will receive one rig. But as we well know, most users of bearing test rigs run multiple rigs in parallel on the same product, same sample, to get statistically valid results. And so we would imagine that as people adopt this test, they will purchase additional copies of the test rig to allow them to do the multiple testing that's typically required. It's not known at this point how many repeats would need to be done to produce valid statistics. We know that with D3336, for example, that tends to follow Weibull distribution, and you typically need 5 or 6 runs to get a good result. Whereas with D3527, at least currently, you only need to run 1 or 2 tests to get a result that is reported in the GCLB specification requirements. So that part is yet to be determined, actually. Okay, here's a couple of questions from the Q&A. If the rig will be used to test cylindrical roller bearings, should radial load capabilities be optional? And yes, the plan is to have both radial load and axial load capability on the rig.
Well, both, question in the Q&A is, both companies build identical machines. I suspect, from a construction standpoint, they'll be slightly different, but what we're looking for is both machines to give, how should I say, identical results from the testing. So that's really what we're looking for. I'm sure each manufacturer will have some small tweaks and differences in how they construct their machines.
Yeah, so they should be functionally equivalent. They may not look the same, but they will be functionally equivalent given the requirements of the rig. The requirements will be the same. The functional requirements are the same, so the functional capabilities would be the same. Here's a question. Could you please confirm the costing on an earlier slide? It mentioned $60,000 spread over 3 years, but the table had much higher figures. Yeah, as Andy explained, that the cost is not 60,000 over 3 years, but 60,000 plus the administrative fees, administrative costs of running the round robin and running the testing program. So you will note that it costs more per year than 20,000, and it is more in the first year as well than in the second and third years. Andy, if you want to address that costing a little more, that would be fine.
Yes, if I didn't make this perfectly clear, I apologize. Individual consortium members will pay $20,000 each year of the anticipated 3-year project to cover the cost of their test rig. That adds up to $60,000, which is what we were given by both equipment manufacturers as their own internal cost. So you're getting this piece of equipment at cost, not retail. And that $60,000 is being spread over 3 years, $20,000 each year. But that's not all. Southwest Research Institute is not a charitable organization. They're a nonprofit organization, but they're not a charitable organization. They have costs, and they will be charging for their administration of this project. And the members will pay their equal portion of those administrative costs. And as I pointed out, the more members we have, that administrative cost is a fixed cost. So the more members you have, the less each member will have to pay to cover the Southwest Research administrative costs. Additionally, as I pointed out, there is an additional equipment evaluation and validation charge that both Kohler and Phalanx will incur in year 1 when they build that very first rig, which they will keep for the round robin testing. That very first rig obviously is going to have to have a much more rigorous and arduous process of testing to make very sure that everything works exactly the way it is before they start cranking out other machines. And for that reason, the cost to build that first rig will incur that additional testing and validation cost, and equipment and consortium members will be paying their equal portion of that as well. And that is why that bar chart and the table costs for each consortium member is more than just $20,000.
All right, thank you, Andy. Appreciate that explanation.
We got another question, was just to confirm members would each get the test rig at the end of the project. So the answer is yes. I will preface that with you must remain a member of the consortium throughout the entire project in order for you to keep the test rig at the end.
All right, another question was how much work has been done to date to identify the test conditions and endpoints, or is this starting from scratch? Not really from scratch, because it's based on our experience with tests like D3527 and D3336. So the range of test conditions that are in the functional requirements of the test, which Andy presented, are based on our experience, our being NLGI and ASTM Subcommittee G experience with bearing tests over the years, and then coming up with what we anticipate to be the right set of conditions for each bearing type. Now, as far as endpoints or failure modes, that's still yet to be determined pretty much.
And we have a question in chat. Will we get a copy of this presentation? Yes, you will get a copy. There'll be some more stuff posted to the NLGI website and on LinkedIn about the consortium.
Another question is there a proposed test method in progress? Test method writing is not quite started yet, but that will commence relatively quickly once we get the consortium in place and get the construction of the machines going to go out to the various cooperators in the program.
No question. we believe you said NLGI will be sending their test rig to Southwest Research Institute. Will Southwest Research be receiving one of each machine to test? At the moment, they will just be receiving like everyone else, they'll get a random test rig from one of the manufacturers.
Here's another question from the chat. How do you have standard test bearings? Oh, we talked about that one already. Then the follow-up to that is that user has experience with FE9 and asked about parallel rigs, so parallel tests. So yeah, we anticipate, like with D3336 or D3527, that multiple tests would be run on multiple rigs to produce statistically valid results.
Another question here, is the 3-year plan reasonable? Could it go into the 4th year? We believe the 3-year plan is definitely feasible. I think Andy mentioned, the manufacturers are already down a path of starting construction and testing of these test rigs. So from that standpoint, construction is underway. Worst case scenario, our thought is if it does go into the 4th year, you're probably looking at more things around round robin testing, so it wouldn't be design changes or anything like that. So we could see it drift a bit, maybe into the 4th year where we're doing a little bit more testing to generate some additional data. But from that standpoint, more to come on that. We'll develop a contingency plan if there is a 4th year.
Yep, exactly.
Yeah, no question. Will members get the equipment at the end of the 1st year? Yeah, that's our target, to have everyone by the end of 1st year have their equipment. So 2nd year, we can start the round robin testing and any modifications to the test rig, and give people plenty of time to start testing everything. As you can imagine, number of different bearings and a number of different grease types will be examined. So the matrix will be fairly large. So we do want to make sure we have plenty of time to do the testing.
Yeah, the manufacturers will be building the rigs, and they'll build the first rig, do the validation during the 1st year, and probably once some of that validation gets completed, start building additional rigs during that 1st year for distribution at the very beginning of year 2. Here's an interesting question, Gary. You and I think we saw it together.
Yeah.
What happens at the end of this program when we found that one machine is better than the other? We really don't anticipate that. We feel like we've tied down the functional requirements well enough, and we'll do so further as we go through the validation testing, so that the machines will be functionally equivalent, and there won't be one that's, quote, better than the other.
And more of a comment that came in from someone, great initiative for our industry and customer expectations. I definitely agree. I think it's great to see NLGI take the lead on this to make it sort of start happening. I think a lot of us in the grease industry, as Andy mentioned, we've seen struggle with a lot of these older test rigs. So it's nice to see a new one coming forward, and hopefully in another few years, it'll be fully commercial and a new ASTM test method to go with it.
Yeah, as we all are kind of aware, if you go back multiple decades, there was more initiative within the oil industry, the grease industry, and within the testing rig construction companies to put time and effort into building test rigs. So that's where D3336, actually that came out of some Navy work, I think, as well. And then D3527 came out of the efforts to put together the GCLB specification. And there's just not been a whole lot of incentive for new rigs to be developed over the intervening years. I know there are things like the FE9 and such that are out there, but to come up with a rig that is of moderate cost yet has a lot of capabilities, not so much. And so I think it is a very great thing on the part of NLGI to put some backing into this and get this rig moving, because we have had a need for it for quite some time. Let's see, are there any other questions or comments out there? I'm not seeing any additional. Oh, looks like we got a new one in the questions. When is the deadline to join? What's the minimum amount of members? What if the minimum amount of members is not reached? The minimum number we have at this point is 15. And the more the merrier from there. We project 25 would be a nice number, but if we had 40 or 50, that would be great too. And our equipment manufacturers indicate they are capable of producing whatever number of rigs we need to accommodate however many participants we may get. So that there is no maximum in the numbers, just that minimum of 15. And then one more, I ran D3336 for many years for the RAF in the UK. This next move is fantastic. So thank you very much for that comment.
Okay, seeing no other questions, we'll close out today's webinar. Thanks everybody for joining.
Hold on, there's another question in the chat.
Oh, okay.
What type of grease samples are to be evaluated in the round robin schemes? Are they going to be fully formulated commercial samples? Who is supplying the samples? That's a lot of good questions yet to be determined. We will comply with the requirements of an ASTM interlaboratory study. And as Gary mentioned earlier, the fact that we're going to have many different bearing types, multiple bearing types, multiple conditions, as well as we'll have to have multiple grease types. Some may be commercial products, some may be lab manufactured batches, and all will be donated through the ASTM Interlaboratory Study Program that will get this commercial or this rig standardized as an ASTM test method. So as far as what specific products, we don't know yet, but we'll definitely have a range of products representing different levels of performance in the different bearings.
Okay. Seeing no other questions, Andy, if you'll flip to the next slide, we are popping up a QR code here. This will link you to the survey that I mentioned at the start of this webinar. It's a very short survey, only 3 questions. It's also available. The link is in the chat from the first part of the webinar. Please complete this for us. This is to let us know that you are either interested in joining the consortium or you have more or deeper questions and you would like one of the gentlemen to reach out to you for without further ado, I'd like to conclude today's webinar and thank you all for joining. Have a great day.
And with that, this presentation is concluded. I'll hand the reins over to David and Gary for questions.
You want to take the first one, Dave?
Yeah, I'm unmuted and moving to the so hello everyone, and we have one question so far, and that is the stakeholder cost fixed regardless of the project duration, or would it increase if the project takes longer than 3 years? And our anticipation is that the cost is the same whether it takes 3 years, 3.5, or more, simply because you've already paid your buy-in over that 3-year period. What is the desired number of consortium participants? Minimum of 15 and as many as we can get. The cost per participant goes down as the number goes up. As Andy has already described, it will approach 20,000, although it will never get to that point per year. And the more the merrier, especially with the generation of test data to produce this new test method. The more participants, the better for the interlaboratory study, round robin type data collection.
Yeah, next question was, what if we don't get enough members? Obviously, we don't get enough members. The consortium idea was sort of, just be canceled. I think what you'll probably end up seeing is sort of the equipment manufacturers themselves going forward and developing the equipment. Much as Andy already mentioned, they're already down the path of starting development. So that would be a likely scenario you would see in the future if we did not get enough members.
Another question is, as a member of D2G, I have not seen discussion on this method. Is there a sketch of this method put together? The test method will be developed during the first year to 2 years of the consortium and then distributed for use by the consortium members to run the tests during years 2 and 3.
Next question was, when is the deadline for joining the project? No firm deadline yet, but our goal is we're hoping to start the survey sometime early next year. We do understand, there's going to be legal reviews and obviously, business reviews internally with each company to get things approved and certified. But we're targeting early next year sometime. Hopefully that would be the goal for kicking off the project. But we are looking for commitments right now to understand, are you willing to participate? And if you need more information, always we'll be following up with you.
Another question is, what will happen in years 1 through 3 of the project for participants? Well, as Andy described that very well already, but year 1 is development of the test rigs, verification of the prototype rigs by the manufacturers, and then years 2 and 3 would be construction of the additional rigs, followed by the testing of greases on those rigs to produce the precision data required to produce a valid ASTM test method.
Next question was, how can consistent bearing quality be ensured? And would the rig at the end have European Declaration of Conformity? For the bearing quality side of it, I think getting ASTM involved and making sure the specification when it's issued, defines that very clearly. I know ASTM is going through a lot of those issues right now on bearing quality. So that would be something we would be watching closely. Along with sort of the round robin testing initially, we'll try to clarify the quality issues. The last part around the declaration, I think we'll factor that into this whole project. Hasn't been something that's come up yet.
Well, we appreciate that input. Another question is, it was said that NLGI would participate and purchase a machine that would be used at Southwest Research. Will this instrument be owned by Southwest Research Institute for future testing? Would this be held there to support labs who don't have a machine and would like and want to do HPM testing? The idea behind them having that rig is to have their participation in the round robin testing, yet not own the machine. NLGI will basically pay for it and house it there during the testing phase. And then the idea at this point is to have a university, an academic organization, own that machine going forward. It would be donated to a university somewhere. Some lucky university would inherit the machine, and they would be able to run tests on it. Southwest Research may want to purchase that machine at the end of the consortium, not known at this point, but that would be one possibility, although that's not what is in the plan at this point.
One question was, well, we have an overview of the budget as the project progresses to track yearly expenses against contributions of the consortium members. I would say yes, that's something we would expect Southwest Research Institute to report out continuously throughout the year, both back to NLGI and to the consortium members.
Another question is, how will formulation of test greases be handled? Will commercial greases be used? That's yet to be determined. We will, as part of this project, request the donation of grease samples to be used in the round robin testing. And those who donate samples may formulate specific products as lab batches. They may send commercial products. It's yet to be determined.
And a question from the chat is bearings per shaft, how many test bearings in all? I believe we're looking at one test bearing. Is that correct, Andy? I know you're more involved with that.
Yeah, I'll grab that one, Andy. I believe it's going to be one support bearing and one test bearing. And another question from the chat is, will the new test rig be suitable for leakage tendency as per D4290? Not planned at this point. That may be an outgrowth of this test, but at this point, it's really a life of grease in various types of bearings rather than a leakage type test.
And we have a question in chat. Would you like Chinese companies to participate in this task? Absolutely. This is a global consortium, so we're looking for participants from anywhere. There's no restriction by country, unless there's some legal requirements for U.S. laws, but we're looking for participation from anybody.
And I'm not seeing any additional questions at this point. Oh, how many organizations have expressed interest so far? That's what we're trying to gauge with this presentation today. We have another one next Tuesday, basically a rerun, repeat of this, although it will be live. And you're welcome to join that one as well, or have other people you know. If you know someone else who might have interest, let them know that we'll be holding another session on Tuesday next week. And then we will be gauging interest based on this presentation. In fact, Andy, why don't you switch to the next slide? And there's a QR code on this slide, and if you are interested, we can start. You'll be able to scan that code and express interest in being part of this consortium. So there's the QR code. Another question is how will you collect those interested in participating? Will this be sent out to those attending for commitment? Actually, it's up to you to express interest, and you can scan the QR code. You can email the NOGI headquarters. You can email Andy or Gary or myself. Any way you want to do it to let us know you're interested in being a part of this consortium. I saw another question pop up in the chat.
A question that came up. How will formulation of the test greases be handled? We're still working through that part right now, but there's some indication we may use some standard reference greases NLGI has already, or reach out to some member companies to see if they're willing to donate it. But it would be ones we think are well known and commercial already, or some that have already been standardized from before. So, but more to come on that, I think, as we get into the consortium.
A couple other chat questions. Will the new test have runtime and off time for existing test methods? That's the anticipation, is that it will simulate runtime and off time or pause time during the course of the test. Of course, we'll work to develop the parameters of the test as we put it together. And so that is really yet to be determined, yet that is the anticipation at this point, that it will probably be a 20 hours on, 4 hours off cycle, similar to D3527 and D3336. Another question from the chat is there a possibility to include a noise test such as ultrasound detections possible, 4 probes attached in strategic places? That is not part of the scope of this test method. It might be able to be added at some point by the manufacturers of the equipment, but it's not part of the scope of the test as put together by the task force. Another question from the Q&A. Have you generated a test rig parameter wish list? Well, yeah, we have. It's on those last 3 or 4 slides. For grease applications, RPM range is up to 3,600 RPM. Bearing loads, that we do have a range of loads we have in mind, as well as a range of temperatures the rig should be capable of. So yes, all those important bearing parameters have been determined, or at least listed.
Another question came in chat. Is there any target life of the test in terms of hours, or is it open-ended? I think that would be part of what we want to do during the round robin testing, sort of define it. I think having an open-ended one, probably not the best choice because you could run thousands of hours, but I think we want to try to find something that's reasonable to be able to differentiate greases, let customers, be able to do enough tests.
Yeah,
during
we
an
want
R&D period.
we want the test to be severe enough that it doesn't last forever. I mean, we don't want to run 6 months to get a result, obviously, but we don't want to run one cycle and have failure as well.
Yeah.
So we want to have a test that is severe enough to differentiate, as Gary described, yet that not so severe, not so lenient that it takes a long time to get results, and not so severe that it doesn't differentiate very well. So we will be determining the test parameters required basically for each bearing type, as well as what needs to be tested for particular applications.
Another question we had was, have you generated a test rig parameter wish list for grease applications, RPM, bearing loads? At this point, no specific things there, but I think that's sort of one of the reasons we want this new test rig. If you looked at the HPM discussions over the past year, there's 2 elements to HPM we're looking to add in the future. One is long life and one is high temp. So you can imagine each one of those claims would have some different parameters. So we're hoping the rigs will be able to do both of those. Another parameter could be, there's been talk about, do we create an electric motor specification? So we're hoping with the flexibility of this test rig, we'd be able to develop some different parameters more targeted to applications, or at least give the participants and the companies the ability to modify the rig to do those if they wish to.
Another question that came in is, how much testing do you anticipate or you expect to be required of the consortium members? There will be several greases involved and multiple bearings types involved. There will be, what we will do is follow the ASTM requirements for interlaboratory studies to have enough degrees of freedom in the testing to generate the statistics, the reproducibility and repeatability of the test. So there will be considerable testing required, but all of that goes into you being more familiar with the test rig and how your greases perform. And that kind of leads into the next question. How will you decide on the threshold for high temp or long life tags? This is within HPM. Benchmark versus commercial products, perhaps, and probably, yes. We would want to benchmark against existing products that we know perform well in the field, yet we will probably have some additional parameters that we will throw in as well on those specifications.
All right. We have a question that came up in chat was, can I introduce a Chinese company to join this task? Maybe they can participate in the design and manufacture the new rigs. Yeah, so I would say if you got a manufacturer who might be interested, I would say send us the information. We'll have to discuss it. Like I said, we are pretty far along with the equipment companies already. So we'll have to look into that a bit more detail to make sure it's not too late probably on their part to join.
We did some surveying and sent out a lot of information, like through the NLGI website and other venues, trying to get gauge interest from equipment manufacturers around the world. And we had very little response other than the 2 here in the US, Phalanx and Kohler. So we would welcome others to join, but we just need to make sure that they get in early enough that their rigs get included in the testing program.
We have a question. What would the maximum radial loading be? I would say at this point, we haven't defined that yet, but I think that would be part of the round robin testing and feedback from participants. What's a reasonable number to set from that standpoint?
And we look at what D3527 and D3336, FE9, and other standard tests these days use as both axial and radial loading, and probably work from there as starting points. All right. Any other questions?
Okay. Well, thank you all for joining us today. If you are interested in joining the consortium, or we've piqued your interest and you would like to have a further detailed conversation with one of these three gentlemen, you have further questions, etc., please fill out this survey. That is the way that we will know that you are interested, and we will get in touch with you very, very soon. So thank you all for your participation today, and enjoy the rest of your day.